Alright, section 10.5 is independent and dependent events. It says here an independent event. The outcome of an event does not affect the outcome of the second event. A good example of that is flipping a coin. No matter what I get the first time, it does not have any bearing on what I get the second time. There is a little formula for that here. It says P of A and B equals P of A times P of B. A good example of that, if I look at flipping a coin, it's 1/2 is my probability of getting heads, so I would multiply 1/2 times the second time. Let's say I want to get heads again. Probability is obviously 1/2 as well for that, so if I multiply two together, it would be 1/4. So what's the probability of getting heads and then heads the second time? It would be 1 out of 4. All right, here's another example problem. It says you spin a spinner and flip a coin. Now understand what I do to that spinner has no bearing on what I flip here with the coin. So it says what's the probability of spinning a prime number and flipping tails? Well, 5's a prime, 1's a prime, 2's a prime, 3's a prime. So 4 out of 5 of my numbers there on the spinner are prime numbers. So 4 out of 5 is my probability of spinning a prime number there. I'm going to multiply that by, we just did it on the last slide, the probability of flipping tails is 1 out of 2. So if I go ahead and I multiply these together, I'm going to get 4/10. Of course, I can reduce that down to 2 over 5. So what's the probability of spinning a prime number and then flipping tails? It would be 2/5. Alright, a dependent event is when the outcome of an event does affect the second event. As it says here, the probability of A and B is probability of A times the probability of B after A. Now this is not as bad as it looks. You just have to first of all think about a dependent event. If I have some cards and I draw a card the first time, when I go to draw another card, obviously there's a different number of cards, so the probability the second time is going to be affected by what I drew the first time. Let me show you an example. Let's say I have 10 cards and I draw, or 1 through 10, I draw one of them. Well, what's the probability of drawing a 5? Well, it's 1 out of 10 because I have obviously 10 numbers to choose from. The second time, if I go to draw another card or draw another number, there's only 9 cards left, or 9 numbers left, so it's now 1 out of 9. So let's say, yeah, the second time I was wondering, what's the probability of drawing a 4? Well, so that would be 1 out of 9. So 1/10 is the first time, and 1 out of 9 is the second time. So what's the probability of first drawing a 5 and then drawing a 4? It would be multiply these two together. 1/90th, so not very good odds if I want to draw first a 5, then a 4. Alright, let's put this into an example. This is people randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What's the probability that one of your relatives is chosen first and then one of your friends is chosen second? Well, the first time, your probability would be 5 out of 100 because there is a total of 100 people and there's 5 of your relatives. By the way, we could quickly reduce that, make life a lot easier on us, would be 1 out of 20. We need to multiply that by the probability of the second thing. There is 6 of your friends. Here's the key though. One person has been chosen the first time, so there's actually only 99 people the second time. So we're multiplying the probability of A, which is now 1 out of 20, times 6 over 99. Again, let's reduce and make life easier on us. 6 divided by 3 is 2. 99 divided by 3 is 33. Just simplify things a little bit more. So when I go and I multiply 1 times 2, it's going to be 2. 20 times 33 is 660. I have to reduce. By 2 is 1. By 2 would be 330. So what is the probability? Obviously not very good odds here. You got 100 people in the audience and you want to know how many, what are the odds of your probability of your relative going, then one of your friends. It would be 1 out of 330. Alright, quick practice problem for you here. I'll just give you one to try here with the independent events. First of all, I'd like you to tell me if this is dependent or independent. And then obviously I'd like you to solve it. When they're talking about spinning, go back to the earlier in the video, it was a spinner, and you had 4 numbers on there. And we want to know what's probably a spinning multiple of 2 on that, and then flipping heads on the coin. So is that dependent or independent? And then what is the probability of doing that? Good luck, and we will see you tomorrow.